Amazing, and we're live. So let's do this again. What are we gonna fix today? So yeah, in yesterday's stream when we finally got the filtering working, it died after a few samples, or rather after a few sample blocks. Oh shit. Okay, cool. Sorry, I added all the Discord crew, which is a crew that's original. Anyways, so here's the thing. So yesterday, when we got to a point where we added filtering into our code, it sort of started breaking, and we ended up causing this. So we have this sort of output, and I think I can just hook it up right now and show it to you guys. So at the moment, our code tries to one moment. So I need to get the that's insane, but it doesn't really matter. Couldn't even tell. There's another notes we want to show. Remove this as well. Let's leave this in as well. No, this is the wrong project. This is the PR. Okay. T-R screen. Yeah, so we want that. Connect that. Running the app on the thing already, it should show up. So I'm just gonna cause the crash, and then we can see the crash, and then we can think about how to go about fixing it, so that we can fix it. And the way I'm gonna cause the crash is I'm gonna trigger the recording, and then you'll see what happens. I should have a Bluetooth app somewhere here. Bluetooth. It's a Bluetooth device. Oh, okay, cool. Let's connect. Amazing. Like within the fast, and I don't think it's gonna do another one. Within the fast, how do I call it? Within the fast sampling. Within the first time we sample already, or is it the second time? No, it's actually the first time we sample. The first time we sampled, we already ran out of data, and this is because we're filtering. You see, we're consuming samples. Yeah, we're consuming samples, and then we're filtering, and then we're consuming samples, and then we're filtering. And the problem here isn't that our filtering isn't working or our sampling is not working. Really, the problem here is that we're filtering while sampling is going on. I don't know if that makes sense. So because we're doing something real time, there's sort of like two deadlines we have right now. There's a very hard deadline, which is collecting the audio samples, because the audio samples is a continuous signal from the real world. Rather than the digital world, the discrete world, not the mathematical world, the discrete world, the discrete mathematical worlds, because not the calculus world. Okay, so the way sampling happens is you stop and you sample and you stop and you sample, and because every time we get the block, we want to filter it. It basically we don't clear the memory blocks and quickly enough, so we end up getting a long backlog of filters, and then that causes the app to crash. This is crashed right now. If I remove the filter, you will see this will be fixed. Let's see. If I remove the filter, I should actually clean that up today. I will. No. So, yeah, cool. That's much better. I don't like that's there, but that's okay for now. I'll fix it just now. That shouldn't happen. But if we remove this filter like this, you'll see what happens. So, and then we remove this part, and then we say yeah, and then Control Shift T, and then we go like Control R, West build. I was looking for that yesterday, the native one. Control R, activate, and then Control R, NRF. Yeah, let's do that. Let's build a pristine quickly. And this should fix it for us. This should fix it for us. This should actually fix it. I'm gonna close this. I'd really like to close that. Yes. And then even this, I can just do that. That's cool. And then I can close this, and then Control Shift T, and then I can move. I like my coding to be on this side, and let's see. Once this build completes, we can copy the compile commands. I have a feeling that it is here. There's the compile commands here, but maybe it's just run out of sync, and that's why we are seeing the build errors. But the thing that is happening is we're filtering too soon. What we need to do is record the audio segment in its entirety, and then put it in a certain place. Once we finish recording, we can go and do the filter, because the filtering takes time. So we need to separate both of them. And I wrote a few notes about this while that build is going on. I wrote a few notes about this. And today, the kind of thing that we're meeting today is almost like a false. It's like a false wall. It is a real wall. You have to you really have to deal with it in order for you to work on it. But really, it's also a false wall in that. It's also a false wall in that it's not. It's like a red herring of a problem. The way you fix it is by fixing something else. And in theology or something, in writing, in the philosophy of writing, theosophy. I don't know what that is. This type of thing is called a guardian of the threshold. And a guardian of the threshold is like a final boss in a level in a game. When you get to the end of the level, you have to conquer something at the end of the level. And if you conquer that something at the end of the level, you can go to the next part. So, anyways, I wrote about this. A guardian of the threshold is a menancing figure which manifests itself as soon as the student of the spirit ascends upon the path to higher worlds of knowledge. So, I think that's up here. This thing that we've met. We've just realized we've made a working filter. We've made a working sampler, but we can't combine them yet. And we need to learn a new technique. And this is kind of making the app more real-time than I expected when I started this. It's becoming a real-time app with real-time deadlines and that are enforceable, like they're enforceable by nature. So if you don't record the audio quick enough, you won't be able to do the thing. Let's see if the build is done. Yeah. So first of all, cp build compile commands here. Yeah, cool. That should maybe fix and vim for us. Control E, audio C, J. Yeah, I thought it would. So, okay, cool. So if I run that application that I just built, my mouse likes dying during streams. I don't know why. I have no idea why this mouse always dies. Anyways, Control Shift, I think T. Control T, Control Tab. Okay, yeah, I can do this. I can do this by hand. What do we need to do here? We need to do something of a pack. So HW. Yeah, cool. So this is just a command that packs the thing, and then Control R, and then I think DFU. So this is just an app, a command that loads the thing. I'm gonna run it. I'm just gonna run it. I'm going to run it, and then I'm gonna run the logger again. I'm gonna run this so that we can see. Yeah, it's been programmed. Yeah. Let's do that. Let's wait for it to go on. That's not a good thing. That's not a good thing. Or it's already gone on, maybe. So let's connect and we should get something. Yeah, so okay. Yeah. 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 See. What is happening? What is happening? Yeah, they're connected. Anyways, let me just disconnect this target and then put it back in. Cool. Let's do that. Reconnected. Yeah, this is good now. So let's just send some audio in there. I'll connect it and then you'll see that the audio now does not stop. Yeah, it'll just keep sensing audio for long. It'll sense audio. It'll do 3 blocks, stop, 3 blocks, stop, 3 blocks, stop, 3 blocks, stop. But the whole thing I'm trying to show here is that if we do not filter, our sensing goes on okay. And if we filter without sensing, that also happens okay. So what we need to do is combine them with some sort of deadline in between. Okay, cool. So now that's been demonstrated and my mouse is working. Cool. So the intention here is that we now want to, rather than this stuff, all of this work we're doing here, all of this processing work of the samples should move to another thread. So I want to add another thread that does it. And also at the end, we might have to add we might have to do some work in our finite state machine so that we can make sure that when you finish mic capture, so let's go to our FSM. Let's go to our FSM service. So I want it so that when you finish mic capture, you can actually go into something like you can go something like filtering and inference or something into another state, so that when you get, because see, when we get into connected, entering connected state, that's fine. Do we do anything? We never get into mic capture. So I want to get into, from connected, I would like to get into mic capture. And then from mic capture, I would like to get into filtering. But why don't we just make the thread first and then we hook it up into our finite state machine so that it actually works. Main. Yeah, main.c. So let's add another thread here. So let's add a k thread define, and then I want to do filter inference thread thread. So we do all the stuff we need to do in here, and then this is going to be thread stack size, and then here we're going to do inference thread run, inference thread run, and then this should go like null again, and then this should be as important as the audio thread, so 4 and then 0 and then 0, and then cool, that's it. We can actually go look at that function that I just used quickly so that I'm not making it so hard. Define yeah, this one. So let's just demystify the stuff that we're working through so that nothing is insane. So we can create threads, and the way we create threads, we use kthread define. I think this macros should be somewhere here. Kthread define should be here. Thread creation. sorry. Zephyr API. I know the things. I just want to do it so that anyone who's watching and doesn't know what I just did can follow. Okay, thread define. And also, it's pretty good to like just review stuff so that you don't write something long. So we entered the name of a thread, we entered the stack size of the thread, we entered the entry function, we entered the three first the parameter 1, parameter 2, and parameter 3 of the entry function. So our entry function is going to be expected to take 3 parameters. We're not using them right now, so it's fine. That's why we all set them to null. And then we enter the priority, which is the one I made sure it is equal to the audio thread. And then we had options. For now, I think those are there's no options there, and then there's delay. And all of these are described here. So name of the thread, stack size in bytes, thread entry function, first to third entry parameter, and then the thread priority, thread options, and the scheduling delay. So scheduling delay is like how long do I wait until this thing starts, and you can have many options in a thread, and it will determine how the thread runs. Okay, cool. So there's that. I don't need to do save in the browser. Okay, I know you don't know. I know you don't know. I don't know where that is. So include. So let's call this inference service. H. I know. PV. And then here, let's actually make a new one. Let's make a new file. Inference service.h. Inference service.h. Enter file. Yeah. Let's save it, and then let's do a split. Okay, a split, and then let's do control WW. Yeah, let's go here. Start PV, and then in here let's open something like let's do FSM service, so we can control start PV. Let's use start PV, and then let's open something like the audio service maybe. Audio service. No, that exposes too much. I want something really simple. BLE service. Yeah, something like that. Okay. Let's do if hash if and if not defined inference service H. Please define inference if and def. This should be the same. Yeah. Please define inference service H. Okay, cool. And then in here, I don't need to include anything yet, so I'll leave it, but let's add this so that if someone uses this from C++, they can use it. If def C++. Okay, cool. And then let's do an extern C, and then open that, and then after that we can do an and if. That actually fixes quite a lot. And then I need to control W, hi, and if. And then what else do I need? I need something at the end. Okay. And then here, that's that. And then I just need to do an and if here. Cool. That actually makes it for us. And then I remember in main I think where we just created this thing, we need that. Control WW. We need a void. We need a void inference thread run. Yeah, and then this takes in a void arg1, and void arg2, and then void arg3. That's really it. That should be really it. Yeah, that fixes it. That fixes it. That does fix it. And then let's look at the BLE service. Is there anything else? Yeah, it takes pointers. Okay. So let's think about it. Let's think about it. Let's just run something in here, and then once we run something, it can be cool. Okay, cool. So this is done. This part is done. Don't wanna split it. No. This is fine. This is fine. And then here we want to make a new file. So we want to make a new file. By the way, one of the other things we need to do is probably move all these headers to their own folder. And then this will look a lot neater. But then when we need to jump it, then it's fine. It's okay. It's cool. Inference. We'll do it at some point in this session. Inference service.c. Yeah. And then save that, and then split that, and then down here we can do PV, we can say inference service.h, and then in here we want to do two things. So we want to do void inference thread run. And then this is void arg1. There's probably a way of just copying this over that I could have done. Arg2, but I find this to be therapeutic and helpful. So arg3. I'm gonna check questions just now. So if there's questions, just tell me. Just let me please inference init. That's that, there's that, and then control WW. In here we can go like void inference init, and this will be nothing, and then that needs a thing that needs to be initialized. So in here I can also go like and then I can go hash include, and then you should be able to find the thing I want. Inference. You should be able to find that, and then in here I want to do a logger module. I do want to do a logger module. I do want to do a logger module. I do want to make a logger module in there. So let's do that. Let's include the Zephyr stuff first. Include Zephyr, and then logging, and then log.h, and then after that, what do we want to do? That's enough, really. Let's label a log module in here so that we can use it to say who we are, module, and then in here we want to say inference module. is fine. That makes it fine. So in here we want to do log1 inference initialized. Yeah, that's okay. And then in here we also want to do log1 inference run has been run, just to test our threads. And then in here, actually what I want to do is, rather than just that, I want a while one, I want to always repeat this, and then I would like to always repeat that. And then after I repeat that, what I do want to do is here is k sleep, and then k seconds, okay, seconds 1. That should be okay. I want to sleep for 1 second. I want to sleep for 1 second. I might want to actually sleep for 3 seconds. That's fine, so that I just don't have some sort of conflict with what's wrong with you? Yeah. So that should actually fix it. Okay, and then I can go down here and I can do a Q PV, and then I can go into main probably, and then main, after all of this, audio P, audio service init, audio service init. After, I will start inference before I start audio, because then I want inference to always be ready. Inference thread init, and then in here I will do inference. Sorry, so I don't know. I don't want to poke fingers into my nose. Just not pretending like I don't do that, but it's itchy for some reason. Cool. So yeah, so cool. So excuse me. I don't know where that's coming from. Nathan would laugh. It's my hay fever coming back. Diff. So we added apply filter, that's fine, and apply filter, that's fine. Okay, cool. So we commented out some stuff, that's okay. And then we added an inference thread, that's okay. And then we run our inference thread, and that should be it. So let's actually build this stuff and see. And while I build, I'm going to jump to questions. Okay, let's jump to questions. Any questions? Hey, Bartholomew, I see you there. Any questions so far? Any questions? I see. Inference. See, yeah, I see it. I actually know how to do that. It's fine. That's the thing that we are missing. We are missing that. That is what we're missing. And there's something else I just realized we're missing. Let's see. Let us see. That's what we're missing. I realized something was missing when I was looking at this code, and it wasn't this. I don't remember. Okay, cool. Okay, cool. Excuse me. So actually what I want to do right now is just to test that the thread runs and that we've just added it to the application file. And if it's running okay, then it's okay. Then we can start actually now moving towards adding stuff in the other sections. Sorry. Okay. Cool. Let's let that build. Let's check if that inference thread actually runs the way we want it to run. I could be doing more stuff. I could be moving. No, but that would kind of confuse. Because I want to move all those headers into their own files, into their own folder. I would like to move the headers into their own folder so that they stay there, but I don't. Maybe if I do it now and then this doesn't work and then we have to like trudge through stuff and that's not cool. So we'll see. Yeah, if you're joining, yeah, check the description below for links to our Discord community where you can come and discuss and get news early about what we're working on and how it's going. And yeah, and meet some of the community members and such. Come to Discord, join us in Discord. The link is in the description. And if you're here, if you're here, just comment about where you found the stream and how you're finding it so far, and let us know. Let us know how we can entertain you better, educate you better, if that's a thing. If you come to these sessions to learn, then cool. That sort of works. That's kind of cool. So let's see if we actually can pack this guy. Pack. I really should rewrite that pack command so it's more clear. That's actually the thing I'm gonna do in a bit. Let me put it in bootloader mode. Perfect. We could put this on MCU boot, and then I could put it next to me, and then if we could get an external power source for it, I could always like just send updates over Bluetooth, you know. I remember I tried to send updates over Bluetooth and my laptop is a bit too old for that. So let's do that. If we can see an inference thread running, we're good. Yep. I sort of knew it would be the one because the first like banner goes up so quickly, so it's fine. In any case, what we are seeing here is that our inference thread is running, and that is good. That's all we wanted to see for now. So inference is working, and we know we can proceed as follows as we need. And at some point we'll tie all of this work into the state machine, but for now, like, you know, let's actually make things work. Okay, so step number 1 has been done. Does anyone have any questions so far? Does anyone have any questions so far? If not, let's now actually go back to our data. Shall we go back to our data? Yeah, let's go back to our data. And that will be, actually want to do Control Shift R, and then I want to do Control E, Control D, Control D, D. That's D. And then I want to do escape. Space A, Control E. Okay. space PV, PF, inference header, space A, and then space PF, and then audio service C, yes, space A, control E, okay, space PF, audio service H, space A. So that way we have everything in our harpoon, and we can just grab it quickly rather than actually going back to the file explorer. Is that how you say it? Okay, so now what do we want to happen here? We want a new memory slab, which we created yesterday. We want a new memory slab that we created yesterday. Oh, I thought I made a new slab. Is that it? We have to share this slab across two modules. That means we have to do some sort of external struct thing so that we can put it somewhere, so that we can access it from another module. Excuse me. Yeah, anyways, let's make it here, and then we'll just start moving it slowly. Let's actually make it work, and then we'll start moving it slowly. So I want to do kmem slab define static. I don't even know if that's a way to do it, and then I will call it infer slab, inference slab. And then I will do block size, and then I will do block count 4. By the way, I want us to note something while we're doing this. Let's actually note something while we're doing this. See here, let's actually note this. RAM used is 54%. Okay. I have a feeling we're gonna run out of memory just right now. I actually have a feeling about that. I have a feeling this is big enough that it's gonna make us run out of memory. So let's actually see what we can do. And then I also discovered something. Anyways, let's move things out slowly. I also discovered this goes somewhere else, this goes somewhere else, this goes somewhere else. That's fine. And even wow. Okay, first of all, save that. Check this. Look at what I just discovered. So, number of taps. Okay, I see what is happening. So those ones go to the other one. Go to the other thread. Okay. Let's go back to audio service and do something. So we made look here, we made an inference slab here. So what we want to do actually is when we are dealing with our here, this all of this work should happen in the other thread. So let's actually just do some sort of thing there. What I want to do is kind of this, and I want to go like x. What I want to do is go to the inference service here. Let me show you. And then in here, what I want to do is here, I want to do SP. Okay. But this is just fine. Don't worry about this right now. Okay, don't worry about this right now. So let's do that. Do not worry about this right now. Let's leave that in there. And actually, I will remove that. I will go like this. You should not do that. this can be like that, that's fine. But what I want to just is to have this one commented out. So I'm trying to kind of visualize how this work is going to, and also this is not good for us, this part. You can't put an end of a comment inside a comment, and you also can't start it again. So we just, let's leave it at this, let's leave it at that, so that we just hold it there. Okay, so let's save that, Control E, and then let's go back to the audio service. See what happens. Okay, so see what happens here. So what we want to do right now is whenever we receive this mem block, wherever we receive this mem block from the, what do I call it? From the I2S peripheral, what we want to do is get this data and transfer it over to the inference thread. Okay, we want to get this data and put it over in the inference thread, and that will cause some crashes in the beginning, but that's the first thing that we want to do. And I think the easiest way to do that is to just copy the whole block at once. If we can just copy the whole block at once, then it's much simpler. And I think to do that, to copy a block, is much simpler than we actually thought. So I think we can just use, I was looking at this code over here, and how this code does it. Control F, process. This code. I was looking at this code, and yeah, this code here. And I think if I can do that, yeah, process block data. What they do, they actually copy sample by sample into their own block that they're going to use. But as I was trolling the internet earlier, I found that I can just copy the whole block at once. Rather than copy it sample by sample, I can copy the whole block at once, which will enable us to do a couple of things. We'll be able to move, we won't have to deal with sample by sample issues while we're doing the listening. And then that also saves us data, because we don't have to have a copy of, we don't have to have another buffer that holds each of the samples in the audio thread. So let's actually try my way rather than copying sample by sample here. So my way involves us doing, I don't know why I always have to do that, but I somehow always manage to want to delete and start again. But my way here goes like mem copy, and then in mem copy we are going to do and so look at this. So we're gonna do this void something like infa block. Okay, so we're gonna do this. We're gonna make a void here of infa block, and then we need to allocate. And the allocation might fail. Okay, cool. Let's just deal with it in here. Let's do it here. For all of them, for all of the blocks, let's kmem slab alloc. We need to allocate, because now this is different from the from the mem slab that we're giving into the I2S peripheral. This one we are managing completely ourselves. And then here we'll do like infa block. Yeah. And then what is the next thing from kmem slab alloc? We need to wait. Inference slab. And then I I think in far block. And then I think we need to give it an and K note. Yeah, we shouldn't have to wait. And equals 0. I don't know if we need that construct there right now, but what's his name? Someone might teach me something right now, and his name is Bartholomew. He might tell me, you do not need .if. You do not need .if maybe. And if I don't need .if, maybe I don't do it. But so once we've allocated this, we need to then do mem, and I'm gonna mem copy. We need to then mem copy, and I think mem copy, the first thing it takes is the destination, isn't it? The destination in far block. And then the next thing it takes is the source, mem block. And then the next thing it takes is the size. This is a size. Okay. So let's actually look at kmemslab alloc just to make sure that it actually does work that way. And then we can go forward. Kmemslab alloc. What does that take? Okay, it takes a slab, an address of the memory slab, a pointer to the block address area. A pointer to the block address area, a waiting period to wait before that. Okay, cool. So, it takes a pointer to a pointer. And that's why, it's a pointer to a pointer. So this is why we're doing an address here, even though this is already an address. So this is a pointer here that is happening. Why do I feel like kmemslab, just give me a moment. Why do I feel like this is gonna catch me again? I feel like that thing caught me earlier and I don't want it to catch me again. This caught me earlier. Ooh, see? This caught me earlier. This gave me a whole week. To get this little guy to work here was 1 week of work. It was like 5 streams of work. We failed so many times. So I don't think I'm going to do it this way. And look at what they're saying. Look at what the example is saying. They make a block like that and then they allocate it like this. So it's twice. I have to cast that into a void. Otherwise you get this error that you can never, it's basically an impossible to diagnose error. I would like to format this code so that it's Ctrl+R clang format, and then not that one today. I want to format source audio service.c so that I can actually see everything. That's okay. That makes it, you see, it makes the code a lot more visible. This sort of works, but this will crash still. But let's see how it crashes. This should crash because I'm not freeing the inference slab. This should crash. Yeah, this should crash because I'm not freeing the inference slab. So let's build it. And as I build, questions. Any questions so far? No questions. No. Quiet as a mouse. I will say hi to Bartholomew. Hi. That's cool. Okay, cool. Building now. Let's see. It's almost been an hour. I'm gonna have to stop on the hour today. The reason being, I've got work. It's weekday. And anyways, we've already done quite a bit. But if this crashes, then at least I can commit it and I can push it up, and then we're done with that. And then maybe I'll do some work on it overnight or something. And then tomorrow we can come in and actually use that thread. Yeah. But I'm not so sure I'm gonna keep going past the hour, because then I have other deadlines and stuff and other things to do. Anyways, so if you do have questions, right now is the time to ask, because I think this is going to be the final run. I have to keep to time so I can get to doing other things. And anyway, I do a live stream every day, so there's enough opportunity to catch on and catch up and hang on. And that's the point of doing it this way, by the way. If we're doing short live streams, then it's easy for other people to keep up and to, rather than do a 5-hour stream like I do at work. I don't stream at work, like I'm saying, rather than do a 5-hour session of work where you completely change everything and then the app suddenly works. But then someone who misses one session is like so lost, and it's fine. I like this one better. Less pressure too. Less pressure too. Less pressure too. Cool. Number one. That if you're South African, you know this. Number one. Okay, cool. I make my own memes. First thing, I am my own meme. I'm dying. This is still nothing. So the first thing I want us to notice is the RAM has significantly changed. The amount of RAM that we're using, we're now using 74% of RAM. And we were previously using something like 60%. But this is kind of not bad. This is not too bad. I expected it to be worse than this. So 30% of RAM left on your embedded device is still okay. And this is still before we do a lot of optimization. There's quite a few variables and things that can disappear because we have a state machine as well. So let's run it. Let's run this and then see what happens. And then I'll commit this, and then we can do that. No. You don't need to do that. Oh yeah, it's parking it. Yes, cool. And then the app is in bootloader mode. And then yeah, let's load up. It will crash because our inference thread is going to be too full. Okay. Yeah, that's my prediction. This should be good. Come on, give us a thing. I don't want that. I want to get the fresh run from boot. Cool. Yeah, so this is inconsequential. It's running inference. The thread does nothing. It doesn't know anything. It's just running. It's just running. So it doesn't matter. So let's connect to it. Let's actually trigger this and then see what happens. Okay. It will crash. And if it crashes because of the inference slab, then we know we're on the right path. And if it doesn't, we're still on the right path. We're gonna fix it. Yeah. Fearless concurrency. Dope. It crashed. It crashed. It crashed. It already crashed. Oh, dear me. Oh, dear me. Else. Oh, dear me. Log error. Could not allocate infra lock. Why? Why could you not do it? I don't know. But show us. Okay. Ret is equals to is equals to that if ret is equals to 0, then do that. Else I have a feeling it's there. It's right there. Tell me how you exploded, and then we stop the session and we know how to go fix it. Yeah, so ret and then if I give it that, it should just go away. Yeah, okay, cool. You expect that. The white space doesn't matter. Cool. Yeah, I know, but I can fix that. That I can do. I can do that from here. Are you happy now? It's fixed now? Yeah, cool. Bye. Okay, cool. So let's run that again. I just want to get the error, and then we do that. We commit. Let's write a commit message. Git status. Git add source inference. Yeah. Git commit dash m inference. Add inference thread. Actually, git add main. See. Git commit dash amend. Okay, that's fine. Git diff. No. Oh no, that's just formatting. Nothing changed. That's all okay. That's okay. Git commit. That's 3 M's. Git commit dash M. Start moving. Filtering to inference thread. Okay, cool. Git add src audio. Yeah. Cool, that's built. Let's pack it and run it for the final time in the session, so that we know what is happening. Okay, cool. It's packed. Let me put this thing in bootloader mode. Yeah, that's in bootloader mode. And then that's a building one. We don't want that. We want this. And as soon as I press it, it's gonna go. And then what we want to do is when it gets to 100, we just want to start it over this side so that we can actually get the thing going. I just wanted to run quickly. 1, 2, 3. Cool. Inference has been run. That's fine. That's okay. And then if I connect right now, we should get at least an error, so that the error just actually tells us what's wrong. Not even an error. That's just an insane immediate crash. So there's an insane immediate crash. There's an insane immediate crash, and I have a feeling it's either because of this, either this, but it doesn't matter because it's already been defined. but it looks like somewhere when we do run this, we mess something up. And let me see. If kmem/dot dot 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 0 printf memory allocation timeout. That's what I did. That's just what I did right now. Return it. It's threatening. But just immediately we touch that, we crash. And it's because we say, okay, no, wait, that's fine. It doesn't wait. That's okay. That's okay. Mem set block pointer. That's fine. Is that what you expect me to do? Is it just a case of like, if I do mem set and okay, just a moment. Oh no, they don't. It could be that. But look, here's another thing. Oh man, it's already over time. But here's another thing. They just use the address. They don't use an address of an address because it's already an address. I'm gonna try that. Inf block 0 and then like this just putting a size. Let's just initialize it to some garbage. Sorry, I know I promised that the other one was the final run, but this actually might just fix everything, and then I'm embarrassed that I didn't know what the fix was. It's usually like that. After the stream, 5 minutes later, I have the fix of the thing that couldn't work. Those three. But we're 5 minutes over. I'm gonna stop soon. Thank you all so much for coming. This is the final run, and then we go off. Yeah. And I have to go get the STM32N6 working, and I don't know how to make it work. Yeah. Any questions? Any jokes? What's your bestest joke? Let's hear it. What's your best joke? What's your funniest joke? Let's see. L is upside down. Whoever keeps liking my videos, thank you so much. Thank you so much. That actually works. Okay, cool. So let's pack that. Let's put that guy in bootloader mode. Yeah, pack it in, and then let's go here and see. I'll be so glad if that even caused like a different crash. I'll be so glad, because for the first time I just followed the dots and they saved me. No, that's an even worse crash. That's an even worse crash. Yeah. Okay. Connect. Oh my what? Oh my what? It works. This is silly. We just try stuff and it just works. Come on. Cool. So as predicted, it does fail where we expect it to fail. It fails because the inference thread does not keep connecting the data. So yeah, this is cool. So this is cool. Actually following the documentation helps. So let's actually commit that. Yeah. /c audio git diff -- stage. Okay. Git commit --m -m inference initialize memblock and copy to it well. Okay, git push. Yeah, git branch. Yeah, git push. This is still in a branch. Git push. Thank you all so much for coming. That was a fun session. We started the beginning of this. We'll go on tomorrow or something. We'll see how far we can get it. But I'm going to find out. The next point is to find out how can we use a memory slab in another. How can we refer to a memory slab from another thread? And then how can we do something like here. Let me show you. So we need to go. Yeah, this is fine now. This should probably break, but I'll see about what to do. Once this 4 is done here, so here, after we do all of this, and we sleep after we give this, we should send a state event to trigger filtering. Yeah, we should send a state signal to state event to send out to start triggering, and then from there on we'll handle it in the inference thread. Anyways, thank you so much for coming today. That was the beginning of adding an inference thread to this and just normal daily Zephyr development work. Cheers. See you guys later. Thank you so much for coming.